Okay, hello everyone. The idea of this video is we created this software for executing relational algebra. The software is called the Relational Algebra Compiler, but actually is an interpreter. And the cool thing about the software is that one can write relational algebra queries and then they can see the result right. The software is implemented in Python and we use pandas data frames, right, to perform the different operations. The goal of the software is not to replace SQL, but the goal of the software is basically for students to be able to practice writing relational algebra queries. If you find any bugs, please let me know. Let me go ahead and start by going to the website. This is the GitHub repository. And let's go ahead. The software was written by Sydney Lynch, which is a student I work with. I'm Ljubomir Stanchev. And let's go ahead and just let's get started. So just for the sake to have something to work with, I created a table of students. Every student has an ID, name, and age. Then I inserted some value into the students, and this is what the students table looks like. Next, let's go ahead and go over, and this using the MySQL workbench. So the software is meant to be used with the MySQL workbench. Next, let's go ahead and look at the instructions and follow the instructions and download the software. So the first thing I did, give me just a second. I guess I'm just going to go ahead and start from scratch. So here we go. So I'm using Windows, and I'm actually using Windows subsystem for Linux. I mean, you can probably run the software under Windows alone, but I found that running the software under Linux is much easier. So first of all, we're just going to go ahead and we're just going to download the software, or we're going to clone it from the GitHub repository. So let's go ahead and do that. Let's see. The other thing I did create is I created this environmental file. This basically specifies the name of the MySQL server. Port number is 33064 for MySQL. And this is just the user, the password, and then the name of the database is going to be the same as the name for the login. Okay. So let's go ahead and go into this directory Relational Algebra Compiler. So I'm just following the steps. And here, we're going to use Python. So we just want to compile everything. And I believe I have Python 3 installed on this version. So I'm just going to go ahead and try Python 3 minus v environment. So we're just going to compile everything. And we're going to try to use a virtual environment. Let me go ahead and pause the video for a second. Okay, let's see. So it says that we need to do some installation. So this is going to be, let me just go ahead and see if I have Python 3.12. Okay, we do. So let's see, I'm just going to go ahead and it asks me to install the virtual environment for Python. So let's go ahead and install this. Sudo Python 3.12. Okay, let me just pause for a second. Okay, so it seems like we need to do some things, and this is on WSL. So we just need to update, to do sudo apt update. And we need to add the universal repository, right? So we are able to use the virtual environment for Python. So just a second. We can just say add repository universe. And we're going to do sudo apt update again. Okay, so now we're actually going to use Python. Let's go ahead and see what happened before. We want to actually do this with Python 3.12. So here, let's go ahead and paste this. So we're going to use Python 3.12. Okay, and then I will do sudo apt install Python 3.12 minus virtual environment. Now everything seems to be working, so we have to install the virtual environment for Python. And then let's go ahead and see if we can run this line again. So it's going to be Python 3.12. Okay, everything's, and then we just use source / virtual environment in and then active. This gets into the virtual environment, and now we're just going to use pip 3.12. This is the version of Python we want to use. Install. We're going to go ahead and we're going to install flit. And then flit install minus sim link. Maybe let's go ahead and see what happened here. I'll just copy and paste this. Here we go. Now I want to make sure I have this file, the environmental file, right in the right position. Okay, so let's see OS. Okay. So here is the environmental file. Everything looks good. And in order to run it, we can just go ahead and let's see, I can just say rec, and this kind of like runs the compiler. Okay. Let's go ahead and look at the documentation, and I'm just going to walk you over the different operations. Let's go ahead. So grammar syntax. So let's go ahead and look at the different operations. So first of all, list. This is just going to show all the tables, right? So you can see all the tables. The drop command we can use to drop, we can create a virtual view, which is only valid right during the scope of the session. And with the drop, we can delete an existing virtual view. So now let's go ahead and look at the different operations. We'll start with projections, which is usually referred to as SPY. So let's go ahead and look at an example of how we can do projections. So here is the student table. So for example, let's see, I want to show only the student IDs, right? So I can say from the students table, I only want to see the student IDs. So as you can see, it's going to be 1, 2, 3, 4. Let's go ahead and see what are the different ages. By the way, if you do the up arrow, we're going to get the same statement again. So as you can see, the ages gives 23, 24, and 27 by default, as expected in a relational algebra. When you apply the pi operator, duplicates are eliminated. If we want to preserve duplicates, we can do projection with duplicate preserving projection. And as you can see now, we're going to get the ages 27, 27 twice. Okay. So let's go ahead and kind of keep going. So we did the projection, selection. We want to get a subset of the students, so let's go ahead and see how it works. So for example, the selection operator is going to be a sigma, and then here we can specify a condition. I want information, maybe as name is going to be equal to Bob, so I want the information about Bob, and then I need to specify the name of the table, which is going to be the students. So here's kind of like everybody whose student name is equal to Bob. This will be the data. Maybe I want to find the age of Bob. So I have this expression, and here I can just say pi age. And here I'm just going to use parentheses. So if I write this operation, I don't need semicolons at the end. It is going to give me the age of Bob. So in this case, the age of Bob is going to be equal to 23. Okay, so let's go ahead and look what is the next operator. So here we just look at projection, selection, group by. So let's see. Let's see if we have enough data to show an example group by. So I have the ID, the name, the age, and maybe every student is part of a department. So we're going to go ahead and we're going to maybe create one more column. So we can just say outer table students add column. So we're going to add a column which is going to be department, and here I probably just say department, which is going to be of type varchar 30. So let's go ahead and see if this works. Okay, and then we can kind of like look at the students. So now we have a department column, so let's go ahead and kind of like set the departments. So we can use the update students set department equals to, let's see, CS, where, let's say, S name equals to Bob. We just want to change the departments for everybody. So let's go ahead and run this. So give me just a second. Okay, so in order to allow updates, we have to go ahead, and I think we have to execute this line. So this line is going to allow updates. And then we can go ahead and say something like update. We want to update the students table. And then let's see. We can go ahead and kind of like do quickly select start from students. So we can just say set department equals to, let's say, CS. And then we can just say where let's say SID equals to 1. So let's go ahead and see if we got this query runs. Okay, this is good. And then we're going to kind of like cover all the students. So student 1 is going to be from the CS. Student 2 is also going to be the CS. And let's go ahead and change on this again. So let's see, student 3 is going to be from the English department. And then let's go ahead and run this, and then student 4 will also be from the English department. Let's go ahead and run this, and then we want to see all the students. So if I run this, you can see we're going to see all the students. So now we have something to group by. So let's go ahead and try this. Here we have the table, so we can go ahead and we can use the gamma operator for grouping. We have to specify what we're going to be grouping by. So we can group by department. And first you specify the group by attribute, and then you specify the aggregation. So for, let's say for each department, we want to go ahead and we can say average age as average age. And we need to specify the name of the table. So this will be the students table. And I believe you don't say S, I believe you just do the arrow, and here we go. So as you can see, for the CS department, the average age is 23.5, and then for the English department, the average age is 27. Okay, let me go ahead and show you just one more thing you can do. Sometimes, if you want, you can just say average age. You don't have to group by anything. So let's go ahead and execute this. And this is going to give you the average age over all the students. So in this case, all the students are going to be a single group, and we're going to get the average age over all the students. Let me go ahead and go back to the, let's see let's see, to the GitHub. So we did the group by. Just kind of go over all the operation. There is an operation to remove duplicates. This is the delta operation. So let me go ahead and show you how it works. So again, if we want, we can go ahead and look at all the, sure, let's go ahead and look at all the departments. So we can just say department, and this is gonna be from the students table. So this is just going to give me all the departments. If I want to keep the duplicates, I can do a duplicate preserving projection. So this is going to give me information about all the different departments. Now let's go ahead and let's see, I want to eliminate duplicates. So I'm just going to run delta. Delta is going to go ahead and eliminate duplicates. And now you're just going to get the different departments. Okay, the next operation I want to show you is the sort operation. So let's go ahead and do an example using the sorting operation. So we can say this is tau, and then let's say I want to sort first by department. Let's say ascending order, and let's say I want to sort by age in descending order, and this is going to be from the students table. So as you can see, the first is CS because it comes before engineering. And then if we have multiple students in the same department, they're going to be sorted by age in descending order. Alright, so let's go ahead and see what is the next operation. So we did remove, sort, and the last one from the unary operations is going to be the rename. This basically creates a virtual view, which is going to be only available during the scope of during the current session, right? So let's go ahead. This is the raw operator. So let's see, we're going to create. Let me go ahead and sure, let's see if I actually, the name of the view should not be the same as the name of an existing table. So let's say I want to create a view v1. I just want to make sure there is nothing. Okay, I don't have a table v1. So I'm just going to create a table v1, and let's see, I can actually, let's see, use this expression. So I'm just going to use this expression. So this expression basically sorts the, you know what, let me go ahead and use the grouping, right? I want to use the grouping and aggregation. So maybe, give me a second, I want to use this expression. Copy. Here we go. So we basically create a view, and here you can specify any expression you want. And here the expression is going to be for each department. We want to find the average age, and we want to store the result in a view v1. Let's go ahead and run it. So if we run this, this creates the view v1. If we say v1, this will be the content. This is the department, this is the average age. Of course, if we want to drop it, we can just say drop v1, which means v1 doesn't exist. Now if we try v1, going to say table v1 doesn't exist, and if we want to recreate it, we can recreate the view, and here is the view v1. The idea of those views is that if you have a really complicated query, it makes sense to actually create several views, and we're going to look at an examples of creating several views before we can actually answer the query. So the actual query is not that long. Okay. So let's go ahead and keep going. So let's look at the union, intersection, and difference. In order to try those, maybe I'll go ahead and I'm going to create maybe a second table, students. So I'm going to go ahead, I have the table students, and maybe I'll create a table new students. And we'll try to kind of like do the different union, intersection, and difference. So I'm just going to go ahead and create, okay, so here is the new students. And then let's go ahead, so I'm going to create this table new students. It's going to have maybe one student ID is the primary key, sure, it's going to have one, it's going to be John, two is going to be John, maybe three is going to be Peter, and maybe 4 is going to be Peter. So we're just going to go ahead and create a second table, new students, and we're going to insert some data. And then let's go ahead and run both queries. And if I just compare the results from new students. So here is the students, we have Bob, Jessica, Peter, here we have something. So first of all, let's do the union of the S names. So we can do something like, we're going to do a projection, we're going to keep the duplicates. And this is going to be the S name from students. This is the first table, the second table is we're going to do a projection, we're going to keep the duplicates. And we're going to again project the student S name, the student name from new students. So those are the two tables. And then if we want, we can apply, we have to put parentheses, right? The software does require to kind of like put parentheses around the two operations. And then we can go ahead and we can do the union, right, of the two tables. So when we do the union, let me go ahead and kind of like show you union. There are two types. You can just use unions, or you can do a duplicate preserving union. So in this case, when we do the union, we don't want to keep the duplicates. So we're going to do a duplicate preserving union. Let me go ahead and pause this for just a second. Okay, so I think what happened here is table new students. Here we go. I didn't type it correctly, so let's go ahead and take a look and see how the union works. So here, for example, in the first table, let's look at kind of like different. Here I have a Bob. There is no Bob, right? So here this Bob, we're going to have a single Bob. Here I have a Jessica. There is no Jessica here, so I get a Jessica, I get a Peter, get a Lubo, and then here I have two Johns and two Peters. Maybe not a very good example. So let's go ahead and modify the table students, and maybe we're going to add one more John, right, to the table students. So let's go ahead and run this. And then we're going to kind of like show the content of the two tables. So the first one, the first table, let's go ahead. And John, we need to change the ID, right? Because this is a primary key, right? So we're going to add to the students table. We want to add John, but the student ID is going to be 5. Okay, give me just a second. Okay, we didn't specify the department. Let's try again. Okay, so this works. So let's go ahead and look at the students table. So here we have, let's say, 1 John in the first table, right? Let's go ahead and look at both tables. So in the first table, let's see, in the first table we have a single John. In the second table we have 2 Johns. So now if we go ahead and if we do the union, we should get in the result 3 Johns, right? We're going to get 1 John from here, 2 Johns from here. So this kind of like the back union is supposed to work, right? We're going to get 3 Johns in the result. Let's go, by the way, what you can do, instead of union duplicate preserving, we can always do just union, and this is going to eliminate all the duplicates from the result. The next operation, so let's go ahead and look at the operation, is going to be the intersection. So let's go ahead and do an intersection. Intersection, and again, as expected, we're going to kind of like keep the duplicates. Okay, so instead of intersection, I think we just need to say just intersect. Intersect. So let's go ahead and try this, and here is what we have. So in the first table we have Peter and John, 1 Peter, 1 Peter and 1 John, and here we have 2 Peters, 2 Johns, so in the intersection is going to be a Peter and a John. Let's go ahead and add 1 more Peter to the first table, right? So we're just going to add 1 more Peter. And now let's go ahead and see what's inside the 2 tables. So this table has 2 Peters, and now this table also has 2 Peters. So let's go ahead and do the intersection. And now when we do the intersection, we're going to get 2 Peters, right? Because we have 2 Peters here, we have 2 Peters here, and when we do the intersection, we're going to get 2 Peters. Lastly, let's go ahead and look at the difference. So let's see if we can just do the difference between the 2 tables. So let's see. So here we have a Bob. There is no Bob here, so we get a Bob. We have a Jessica, no Jessica here, right? So we get a Jessica. We have a Lubu, and there is no Lubu here, so we have a Lubu. We have 2 Peters, but those 2 Peters are deleted by those 2 Peters. Let's go ahead and delete one of the Peters, right? So we can just say delete. From table students, where maybe we don't need the table from students where, and let's see where student ID equals to 4, and this should be from new students. So I want to delete the second Peter. Okay, this worked great. Let's go ahead and run them. So now, as you can see here, we have 2 Peters. We have 1 Peter, and now if we run the query, the 2 Peters minus 1 Peter, and then we are going to get a single Peter in the result. Of course, if we want to, you can always run intersection or difference without duplicate elimination, which is going to eliminate all the duplicates. Okay, let's go ahead and look at kind of like what are the next operations. We do the union intersection difference. The next is going to be the cross product. The cross product is just going to give you every possible combinations from the 2 tables. So let's go ahead and kind of like see what the 2 tables look like. So we have the students table, okay. Then we have the other table, which is new students. It should be capital. And as you can see, we really work on that. The software gives very meaningful errors. If you're trying to use a table, if the table doesn't exist, it just tells you table doesn't exist. So we really spent a lot of time making sure, we're getting kind of like proper errors. So again, this is the students, this is the new students, and now let's go ahead and do kind of like cross product, right? cross product. So this is going to give us kind of like every possible combinations of the two tables. Let me go ahead and take a look at kind of like okay, I misspelled cross product, which is perfectly fine. And this kind of like gives you the cross product of the two tables. So I get the student ID, the name, the age, and the department. And then from the second table, I get the student ID, the name, and the age. If you kind of like look at the first table, here I have 1, 2, 3, 4, 5, 6 tuples. Here I have 3 tuples, so in the result you should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let me double check. So we have 6, 3, so 6 times 3 should be 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 tuples. So the cross product just gives you all possible combinations of the two files. Next, let's go ahead and look at the different kind of joins we can do. In order to do a joins, we probably need two tables. So let's go ahead and look at the students table. So here is the student, the name, the age, and the department. Let's go ahead and create another table about students taking courses. So we're just going to say create table, let's say takes. And we have student ID integer, course ID integer. You can have primary foreign keys, but we're not going to worry about foreign keys here. So student is taking a course, and maybe they got the grade. So the student, the grade, and maybe the grade is also an integer. So let's go ahead and run this. Okay. So table takes already exists. So let's go ahead and drop the table. Okay, and we're just going to recreate. And now let's go ahead and look at what we have in the students table. Okay, okay, I dropped the table students by mistake, that's okay. So we're just going to create the table students again. Okay. And now let's go ahead and insert into the students variables 1, Kim, student ID name, age is 23 years old. Let's go ahead and see if this works. Okay, and then we can insert more. So this is 2. Bob is 33. Maybe that's all we need. So we have maybe just one more. We have 3. Here we have John. John is 18. So we insert some values. And let's go ahead and do select start from students. So here are the 3 students. So now let's go ahead and insert something into the takes table. So insert into takes, and I'm just going to have student 1 is taking, let's see, 365, and maybe they got a 4, right? Let's say 4 is an A. So let's go ahead and make sure this works. Okay, should be capital takes. Okay, and then student 1, maybe they took 366. They got a 3, and then I have student 2 is also taking, let's say, 365. They got, let's say, a 4, which is an A. Maybe student 2 also took, maybe they took 300. And let's say they got a C. go ahead and let's start from students. And here I'm just going to go ahead and run another query, which is let's start from text. Just put a semicolon here. Just going to run those two queries. So here are the students. We have Kim, Bob, and John. And here is the student. Student 1 takes one course, student 2 takes another course. Let's go ahead. Where is it? I want student 1 to take maybe student 1. I don't know. I think we did this 366, and let's see. 3. This works. Okay, that works. And then let's see if we can run those again. So here are the students, 3 students, and kind of like different. Student 1 is taking 2 courses, student 2 is taking 2 courses. So now, first of all, let's see if we want to do a join between the two tables, right? So I can just say students / join takes. And then when you're joining two tables, we can actually do a natural join. So we can do the natural join is going to be on student ID, right? Which is the common column, right, in the two tables. So if I do that, as you can see here, here is Kim. Is taking 365 and 366. It got an A. And here is Bob. Bob is taking 365 and 300, and this is the grade. So for example, one of the queries we want to find, maybe for each student, we want to find the average grade. So we can do something like a gamma, and then we can group by student ID, student name, semicolon, and then we can do the average of the grade, and then we can rename this as the average grade. And then let's go ahead, and then I need to specify here parentheses. As you can see here for student 1, Kim, the average grade is 4, Bob, the average grade is 3. Now that we're doing an inner join, which means that John is not taking any courses. So in the result, there is no information about John. Another thing, so we did the inner join, we can do a left join. So let's go ahead and do a left join. So we're going to do kind of like the, sure, maybe just a left join. And this is the result, so let's go ahead and take a look. So we have information about Kim is taking 2 courses, Bob is taking 2 courses, but for John, if we look at the data, John is not taking any courses. So the course ID and the grade is going to be equal to null. Okay, and of course, if we want, we can do kind of like the query from before. So we can do a student's left join takes. And now as you can see for Kim, the average, the GPA is 4. For Bob is 3, but since John is not taking any courses, then the GPA is going to be null. By the way, if you want, instead of left join, if you want to do a right join, you can definitely do that, and we can just swap the two tables. Takes, and we're going to do students, and you should get exactly the same result. Let's go ahead and do an example with a full join. Let's say full outer join. So as you can see, those are the students. John is not taking anything, and here we have student taking a course. So let's go ahead and add one more thing to text. So we can have student 3 is taking 366. We know that student 3 doesn't exist, that's fine. We didn't enter any foreign key constraints, so this is perfectly fine. If we run the two tables, as you can see here, I have student 3. And now I believe what we can do is we can just do a full outer join of the two tables. So we can do students. Let's see, and I think we can just do just full outer join. Full outer join text. And as you can see, so this is student full outer join text. Okay, this didn't work because here we have student 3 let's go ahead and change. We want to change this to 4. Can we change it here to 4? I don't think we can. Maybe. So let's see if this worked. No, we need to update. So I want to change this 3 to 4. So I'm just going to update. Update students. Update set. Student ID is going to be equal to. Let's go ahead and start with the table students. So let's see. Let's start from students. Okay, so I want to change this to, so they said student ID equals to 4, or student ID equals to 3. So let's go ahead and run this. Okay, this seems to work. So let's go ahead and do select start from students. So now I have student 1, 2, and students. Go ahead and run both of them. Okay, and then just close that, I have too many things open. Just want those 2 results. Okay, maybe it's too much, just students. So here I have student 1, 2, and 4. And then if we look at text is going to be 1, 2, and then I have 3. So let's go ahead and run this query again. And this kind of like what I want to get, right, for John, which is student 4. So here is for John. There is no information, he's not taking any courses, that's no. And then I have a student, which is student 3. I don't know the name and the age because student 3 doesn't exist here, but he's taking course 366 and 4. So this is how the full auto join works. We have one more type of a join. It's not commonly used, but just for the sake of fun, we decided to actually implement a semi-join. And I think all those kind of like expressions refer to the same thing. So let's go ahead and see how it works. So students. So let's see. We can do, let's see, left. For example, can I do left semi-join? Sure. So this kind of like half of a join. And as you can see, this gives you only the students that join with something from text. So in this case, students 1 and 2 write join with something with text, and then student 4 doesn't join with anything with text. So you can write the query like that. I think all the joins we have been using so far were natural joins, right? But of course, we can always also use a join which is not a natural join. So let me go ahead and show you an example. So I can say students, let's see, join text. So this is the normal join, and if we want, we can also do a theta join. So we can actually have student ID equals to student ID. So this is the attribute from the left table, and this is the attribute from the right table. So if you do something like this, you get 2 student IDs in the result. This is the attribute left from the left table, and this is the attribute student ID from the right table. Next, let's go ahead and look at the division. So for example, division, I want to find the name of the students that take every single course. I don't have a table course, so let's go ahead and create a table course. So create table, sure. Let's see, I have students, so I'm just going to say courses. And then I have the course ID, which is an integer. Course name, right, which can be varchar 30. And maybe the difficulty, right, which can be, let's say, of type integer. So let's go ahead and see if this works. The table already exists. So we're just going to go ahead and we're going to drop the table. Okay, and then we're going to create the table. So in this case, let's go ahead and look at what the table text looks like. Select star from text. let's see, should be capital T. So we have 365, 366, and 400. So let's go ahead and create those codes. So we can just say insert into courses values. So the course ID is going to be, let's say, 365. Can be DB1, database is 1, and then the difficulty is maybe 3. And then we can have 366. Database is 2. Maybe it's a little more difficulty, right? The difficulty will be 4, and then we have 300. Maybe this is software engineering, and maybe the difficulty is a little lower. So let's go ahead and try and see if this works. Excellent. And now let's go ahead and take a look at the courses we have. So we can just say select start from courses. It's going to give us kind of like a list of, okay, those are all the courses. Now 365, 366, and 300. Let's go ahead and look at takes again and see what we have. So we have student 1 is taking 365 and 366, and I want student 1 to also be taking 300, right? So I'm just going to say insert into takes values. So I want student 1 to be taking 300, right? Maybe they got a 3, right? This is the... Okay, that worked. And then let's go ahead and do select start from text. So now if we look at student 1 takes 365, 366, and 300. So student 1 takes every single course, while student 2 takes only 2 courses, 365 and 300, and student 3 takes only 366. So now suppose that I want to find those students that take every single course. So here is how we're going to use division. So for example, I can go ahead and start with a projection. I guess we don't care if we keep duplicates. Sure, let's go ahead and keep duplicates. And then I want to get the student ID and the course ID. I guess I don't care about the grade. And this is going to be from the text table. So this is one table. It just gives you the student ID and the course ID. And then we're going to do the divide. And then we're going to use the second table. So the second table, we're just going to say projection. And in this case, we just want the course ID. And this is going to be from the table courses. So this one, if I do the projection of the course ID from the table courses, so this is going to give me 365, 366, and 300, right, will be the 3 courses. And then this table is going to have the student ID and the course ID. So this is going to give me the student IDs of those students that take every single course. So if I run this, as a result, I get the student 1 because this is the student, right, that's taking every single course. And if I want more information, I can do kind of like parentheses. And maybe I want to get the name of the student, right? So I can do something like students join. So if I do, you're going to get the ID, name, and the age of the student, right, that is taking every single course. Let's go ahead and see. So those are kind of like the main operators. And before I end the video, I just want to show you how you can do something more complicated. So for example, let's go ahead and find the student information, the ID and the name of the student with the highest GPA. So if I look at the table text, this is the students and the GPA. Now for each student, I want to find their GPA. Let's see if I still have the view V1. There is no... I think what happened was V1 existed, but we modified the table department under it, right? So that's why we kind of like made V1 invalid. So we can just go ahead and drop V1. Okay, V1 doesn't exist and we're going to recreate it. So we're going to use the row operator. So we're going to create V1 and this is going to be, we're going to use grouping and aggregation. So we're going to get the student ID, and then we're going to find the average grade of each student, and maybe we're going to kind of like rename this as the GPA. And this is going to be from the table takes. Very important, those are the attributes we group by, those are the attributes we aggregate. We have to use a semicolon in between. So the view V1 will be for each student, what is the average grade. So student, let's go ahead and look at the actual takes table, verify everything looks good. So student 1 is taking 3 courses, 4, 4 and 3, so the GPA will be 3.6. Student 2 is taking 2 courses, 4 and 2, so the GPA will be 3, and then student 3 is taking 1 course, the GPA will be 4. So here is the student and here is the average GPA, right? We created a view V1. Let's go ahead and I'm just going to create a view V2, and this will be, we want to find the student with the highest GPA. So this one is just going to find the highest GPA. So we're just going to say max GPA, and we can rename it as GPA, and this is going to be from the table V1. So let me look at it, make sure everything looks good. And here we have 2 tables, right? Here is the student and the GPA, here is the maximum GPA. Of course, what we can do is we can just go ahead and we can join the 2 tables. So if I join the 2 tables, I'm going to get information about student 1, which is the student with the highest GPA, and then I can join the result with the table students. So let's go ahead, and I think maybe I did it too quick. So let's go ahead and do V1 join V2, right? So here is the student ID, and their GPA is 4. So if we look at this table, the student with the highest GPA is student 3. Of course, if we look at the table student, there is no student with ID 3, right? Which is a problem. Let's go ahead and quickly insert the student. So I can just say insert into students, value student 3. This is N, and let's see, N is 22 years old. We can just update this works, and then let's go ahead and do select star from students. So those are all the students. Now we want to find the student with the highest GPA. So we can do something like, we can run this query again, right? Students. So this is going to give you N, and N is the student with the highest GPA. So this was kind of like a quick overview of, let's go ahead and kind of like open this, of the different relational algebra operators. As you can see, we pretty much support everything: projection, selection, with duplicates, without duplicates, grouping, remove duplicates, sorting, creating virtual views, union, intersection, difference, cross products, different type of joins, divisions. So this is kind of like, I mean, it's not as powerful as SQL, but I think it's great for students to learn relational algebra before they learn SQL. So once you understand how the different basic relational algebra operators work, from my experience teaching databases more than 20 years, is that once you understand relational algebra, writing SQL queries is much easier. So feel free, please install the software, try it out, and then if you find any bugs, any problems, please send me an email. I'll include the information in the description. And thank you for watching the videos.